All right, so we're going to continue with our new unit, rational functions, but we're going to continue first by reviewing something, and we'll review our favorite F word in math, factoring. I know you love factoring. All right, so remember, the first thing you should always look for factoring is the GCF. So this first part of this worksheet is using GCFs. So let's look at question A in workshop 1. We want to look for GCFs here. So let's see. 18 and 27, their GCF is going to be 9. So let's factor out a 9. And the GCF between x to the 6th and x to the 4th is going to be the x with the smallest exponent. So that would be x to the 4th. So we're factoring out 9x to the 4th from the numerator and from the denominator. And note, it says that up here. You have to factor it out of each. So we factor out the 9, we're left with 2. If we factor out x to the 4th, we're left with x squared. And then again, we're factoring out the same thing from the denominator. Factor out the 9 is 3, and we factor out the x squared, there's nothing left. So then since we have the same factor in the numerator and denominator, we can simplify, and we're left with our simplified rational function. All right, let's do something a little bit, just slightly harder. G. All right, so G. Notice how we have 2 terms in the denominator. So when we see multiple terms, we want to look for the GCF of those terms. So let's just look for those 2 terms first. GCF between 27 and 18. Oh, these are the same 2 numbers we just used, so that's going to be 9. Only one of them has an x, so we can't factor out any x's. But if we factor out a 9, we'll be left with 3x plus 2. And let's see if we could factor out a 9 from the 27, and we can. 27 in the numerator. So there again, we have the same factor in numerator and denominator. We can simplify, and we get 3 over 3x plus 2. So there is our simplified rational function. So everything in this section will do with GCFs. So please make sure you use your GCF to factor it out and simplify your rational functions. But workshop 2 has to do with a difference of squares. And here are the steps to a difference of squares. First, you should use the GCF. See if you have any GCFs, and then you can factor it out. So let's see. Let's look at, let's look at question D. All right. Again, you can see we have 2 terms up here. So do these 2 terms have anything, any common factors? Do 9 and 49 have any common factors? Well, the only factors of 9 are 1, 3, and 9. And 1 doesn't count. So 3 and 9, they don't go into 49. X squared versus y squared. These don't have any common factors either because their bases are different. So no common factors there. But what we do notice is the 2 and the 6x. The 2 is a factor over here. Can we factor out a 2 from the 6x? And we can. So we're going to have 2 times 9x squared minus 49y squared over 2 times 3x, which means now we can simplify those 2's. All right. So great. That 2 is gone. We don't need to worry about it. Now remember, this part is called a difference of squares. So let's see, is this difference that we have in the numerator, is it a difference of squares? 9x squared, 9 is a perfect square. X squared is also a perfect square. And then 49y squared. 49 is a perfect square. And y squared is a perfect square. So yes, this is the difference of squares. And if you notice you have a difference of squares, what you can do is create this form. So you had a squared minus b squared. and you turn to the a plus b and a minus b. So again, this is all review. Hopefully you still remember this, but we need to basically square root each term. So we'll get 3x plus 7y and 3x minus 7y all over 3x. Now notice none of our factors can simplify now because here's one factor, here's another factor, and here's a third factor. So these three, none of them are exactly the same. We can't simplify any of them. All right, and we're going to work with one more factoring method with our trinomials. So let's look at the next page. So when we have trinomials, the most basic case is when a is equal to 1. We just figure out what we have to add and multiply to, and this is our standard factoring method. So for example, in workshop 3 part A, we want to multiply to 20 and add to 9. What are two numbers that do that? So that would be 4 and 5. So then we'll do x plus 4, x plus 5. But that's the easy case when the coefficient in front of x squared is 1. Then remember we went through the AC method. We're factoring by grouping in the early part of the year, and that's case 2. We use this when the coefficient a is not equal to 1. And we'll do an example. So if we look at example D, all right, we can see that our coefficient, our a coefficient, is 3. So let's use the AC method. Now, the first thing to do is we need to know what AC, the product of it, is. AC multiplied is equal to 3 times negative 5, which is negative 15. There we go. And my 5 looks like a 3. There we go. All right, second step. So factors of 15, and it's a negative 15, so we're going to have a negative one of them, but they're still going to be the same basic numbers. Let's see, we'll either have some combination of 1 and 15 with one of them being negative, or 3 and 5 with one of them being negative. So any way you combine 1 and 15, you're not going to get a negative 2. Like you're either going to get 16 or 14 or the negative version, so negative 16 and negative 14. So yeah, that's not going to work. So let's see, 3 and 5. If we added them, we'd get 8. If we subtract them, we'd get 2, which means it's possible to get negative 8 and negative 2. Since we only want one of these to be negative, since we're multiplying to a negative number, we need 3 and negative 5, because 3 minus 5 equals negative 2. So that's what works. So what we're going to do with these two numbers is we're going to rewrite our b term using these two numbers. So we'll keep a, 3x squared, then we'll have plus 3x minus 5x using the two numbers, 3 and negative 5. And then minus 5 because that was our c term. All right, so we're on our way in the AC method. What we're going to do now is we're going to group these together. So basically the 3x squared plus 3x. And notice how it's a minus 5x. If you see a minus for your third term, you always want to factor out that minus. So minus 1 is what it really is. Factoring out the 1, you'll get positive 5x plus 5. All right, so next we want to see in each of these parentheses, are there any GCFs? Between 3x squared and 3x. Yes, we have GCFs. There's a 3 for one thing. And then there's also an x. So we're left with x plus 1. And between 5x and 5, we have a 5 in common. So we're going to factor that out. So we'll have negative 1 times 5. And if we factor out the 5, we have x plus 1. Now notice how these two are the same. If you have these two the same, then you know you have done your AC method correctly. All right, so what we're going to do is we're going to pair things together. These will pair together. So 3x minus, and 1 times 5 is 5. And these two pair together. So that's x plus 1. So that's the factor version of the numerator. But remember, there is a denominator. So our numerator became 3x minus 5 and x plus 1. And this was over our denominator. And the purpose of this, remember, we factor so we can simplify. And look, these two factors are the same, so we can simplify it. And we're left with 3x minus 5 as our final answer. All right, so you have seen a review of all the methods. In each section basically uses each method, except every section can contain GCF. So please make sure that you're looking for GCFs whenever possible. That should always be the first thing you look for factoring. And then workshop 4 on the last page, this is a combination of all the methods. So you're going to have to look for GCF, you're going to look for difference of squares, you'll have to look for factoring trinomials. Since there are a lot of factoring questions, like you can see these 3 pages contain a bunch of factoring questions. You do have some extra time to do this, so please let me know if you have any questions. All right, good luck and stay safe.